Hi, welcome to this video tutorial. What we're going to talk about in this tutorial is just how to make your very own Clark style zapper based on the Zapperplans.com schematic. If you haven't done so already, go ahead and pull up the Zapperplans.com website and click on the plans link just to get the schematic and the parts list. You're going to need a few things. You're going to need some jumper wires like these. You're going to need a breadboard like this one. I think I paid a couple of dollars for this one. It was just a small basic breadboard. Next you're going to need some alligator clips. These are actually clip leads. You can't see it very well, but they're actually red and black clip leads. They're double-ended, so we can connect them into a set of jumpers once we connect them to this board. Then we've got our 1M resistor, 220K and a 1K and 100 picofarad. So these two resistance values and this capacitor value, they can be changeable depending on the frequency that you want. If you want to find out more about that, I've written a blog post on the Zapperplans.com blog. You can go check it out. I'll try and put it in the YouTube description so that you have easy access to it if you want to change the frequency. But the idea is with digital circuits, the frequency can vary quite a bit, so I can't just tell you, well, use this value of resistor and you will get this frequency, just because the manufactured parts are somewhat different. And what you have to do is you have to get some components and a potentiometer and sort of tune in your frequency with some kind of a frequency meter. We usually use an oscilloscope, but you can use a frequency meter of some kind. Anyway, so without further ado, let's get started. If you haven't used a breadboard before, you should know that the idea of the way it works is you've got these parallel lines, and then you've got these vertical lines. So these vertical ones are a row of themselves, and they're all connected, but they're not connected to the row next to each other. So each one of these rows is disconnected, and this will all make sense when you see how the chip goes in. The chip just connects into the middle here. Let me just snap it down. And so you can kind of see that you wouldn't want the individual points of the chip to connect to each other. And so with a chip in like that, none of those points are connected yet. And if you want to connect any points, you have to do that with jumpers. So now that we've put in the chip, let's just start placing components. Let's start with the 1M resistor. Since on the schematic we want to work, I'm just going to work from left to right. So we'll start with pin 1. You start by connecting the one side of the resistor to pin 1, and then let's just connect the other side to this free row that's right here, because we're going to want to connect a couple other components to that. Next, let's grab this 220K. It'll go from pin 2 and then also to that same row that we just connected our first resistor to. So see, they're both going to the same place. And I will zoom in on this and show you a little bit closer once we have them all placed. Next is our capacitor. That one is going to go from pin 4. So take where you are at pin 2, skip 1, and connect. So you see that they're in different rows. And you notice I'm kind of staggering where I put these so that they don't cross circuit. But I mean, that's not totally necessary because we got plenty of wire length here, but just for the sake of this demonstration, that's what we're going to do. And finally, our 1K resistor is going to go from pin 6. That's the second to last pin here. and that's going to be your output. So for output, what I like to do is connect it to the very end point on the breadboard. So that's our output. That's going to be our output positive. So if that's our output positive, we're going to put our output negative over here. Alright, so now that we've got those connected, let me just zoom in here so that you can see a little bit better. And if you're putting this together, this would be a good time to pause the video and just have a still frame to where you can connect them all together. But I'm going to go ahead and move on. The next step is jumpering. So for this demonstration, I'm just going to use the yellow color for all the jumpers. That way we get some kind of sense of congruity. So again, let's work from left to right. We'll start with the bottom components here, and then we'll go to the top of the schematic and jumper those together as well. So pin 2 to 3 gets jumpered. So out here we've got a space. Let's just go ahead and jumper that. Then 4 to 5 gets jumpered as well. That's just right next to it. So let's just crowd it right in there. And then you're done with jumpering for the bottom. We will do some input and outputs, but as far as these crosswise jumpers, that's all we have to do. Next we need to jumper the pin 14 to 13. This is where our input comes in, and so it's important to note where your input is. Your input is going to be on pin 14, and so we're gonna end up putting like a red wire there just to signify it. But let's just go ahead and jumper it first. So 14 to 13. Next is 12 to 11. And again, you'll notice that these are right next to each other. So if you wanted to, you could stagger them, but I figured for the case of this demonstration, it would be simpler to note how they just go in a row like that. The idea here is that we're tying these gates together to sort of cut down on circuit interference and give you a better output. Now, technically at this point this zapper is done. It just needs power and it needs output. So, in order to do that, I've got some red and black jumpers. And so what I'm going to do is I'm going to set up my inputs and outputs at the ends like I was saying. So the top side is going to be the ground side, and the bottom side here is going to be the plus side. So let's just start here. We've got a black lead, and that goes to pin 7. Pin 7 is where the output ground is going to be. Next, just to keep our inputs and outputs sort of congruous, so that we've got one side that's an input, one side that's an output, we will set up a jumper going from that pin over to the far corner here. Now, in order to do the inputs, the input pin is actually pin 14 over here. So we'll put a red on the far corner there, and then we just squeeze in here get our pin to pin 14. Oh, sorry. That's not right at all. Here. It'll be right next to this yellow. Okay. So we've got our input row here, and we just need one more output. Since the 1K resistor is the output, I mean, we could do something like that, but really what we're going to want for the output is we're going to want some open kind of contacts. And I will get to that in a second. For our input, so now we've got our 9-volt battery clip. You just line up the reds and the blacks, put them in the same rows. And with a regular 9-volt battery snap, these should just slide right in there. But you may have to finagle a little bit. You may have to solder pins to them or something like that. You could just get another set of alligator clips. But those are making a connection. Oop. There we go. So you see how they're in the same row, and so they'll be connecting to the same points. And for our output, we've got our alligator clips. And so what I'm actually going to do here, rather than having extra jumpers, is I'm going to disconnect the red and the black, and then see we've got output pins right there. And then we'll just connect to them. So red to red, black to black, and there you have it. At this point, your zapper is done. All you need to do is hook up a 9-volt battery to this 9-volt battery snap, and then take your output off of these. Now, obviously, for convenience sake, you might want to repackage this a little bit. You know, there's not a whole lot you could do. You could put some electrical tape on the alligator clips here. You could tape the whole thing if you wanted to. But this is just to let you put something together and kind of see how it works. And if you want to vary the frequency, again, check out that blog post, and you can change those components around in order to get a different frequency. We've got some that put out 30 kilohertz or down at like 5 or 10 hertz, and on up into hundreds of kilohertz. You can do the full range of the Hulda Clark suggested frequencies with this zapper setup. So thank you for watching this video. I don't want to waste any more of your time. I want you to get started on putting this together. So just reference this video whenever you want to put one together, and I hope that you have a great time zapping.